Dear friends, welcome to this channel. In this video, I will explain questions from 31 to 40 in JAM 2020 question paper. In section B, we have multiple selection questions and each question carries 2 marks. Let us take question number 31. For the reaction shown in scheme 1, the concentration profiles of different species are provided. This is a scheme 1. This is a concentration profile. Based on this graph, the correct conditions regarding the rate constraints. What is the correct condition? Let us take first condition, K2 is greater than K4. This is the K2. Conversion of R to Q, K2, and conversion of Q to P, K4. Here, if you take this one, this is the change in concentration of Q with time. Initially, the formation of Q is it has high rate when compared with the decomposition of Q into P. Here, in less time, there is a more change in concentration. Here, there is a more time, less change in concentration. It means the conversion of R into Q is fast when compared with the conversion of Q into P. So K2 is greater than K4. This one is correct. And option B, K3 is greater than K1. What is K3? Conversion of S into P, and K1 is conversion of R into S. So this is the concentration change of S with time. If you take conversion of R into S, there is an increase in concentration of S, but it takes more time to increase concentration of S. But when you take conversion of S into P, when there is a conversion of S into P, there is a decrease in concentration of the S. It takes less time. Less time means more rate. So the conversion of S into P is fast when compared with the conversion of R into S. So K3 is greater than K1. And K2 and K1, what is the relation? What is K2? Conversion of R into Q. This is K2, and conversion of R into S is K1. Suppose if you take concentrations of Q and concentration of S, which one is higher? If you take at this time, which one is higher? The concentration of Q is always greater than the concentration of S. It means the rate of conversion of R to Q is fast when compared with the conversion of R to S. So K2 is greater than K1. So this one, K1 not is equal to K2. Since the concentrations of Q and S are not same, so K1 not is equal to K2. So what are the correct options? A, B and C are the correct options. Okay, here wave function is given. The probability of finding the particle between x and x plus dx, y and y plus dy, z and z plus dz can be expressed as. We know that probability to find a particle is psi square into volume element, that is dv. Here volume element is dv is dx, dy and dz is the volume element. This is the volume element. So how can you express psi square dx, dy, dz? If you take A, option A, it is not correct. Here there is no volume element, so it is not correct. In this case, psi square, so modulus psi xyz square dx, dy, dz, this one is correct. And psi square can be written as a psi star xyz into psi xyz dx dy dz. It is also correct, and this one is not correct. Psi star xyz psi xyz. Here integral dx, integral dy, integral dz minus infinity to plus infinity. This one is not correct. Suppose if you take integral dx, you will get x. Integral dy, you will get y. Integral dz, you will get z. Because this is not correct. So this one is not correct. So what are the correct options? B and C are the correct options. In water, the enthalpy of a protein in its folded state, HF, is lower than that in its unfolded state. Means which one is lower? HF is lower than HUF. The entropies of the folded and unfolded states are SF and SUF respectively. The conditions under which the protein spontaneously folds in water at a temperature T. Okay. Okay, what is folding? Conversion of unfolded state, unfolded to folded. Conversion of unfolded protein to folded protein. Then what is delta H? Delta H is equal to enthalpy of folded state minus enthalpy of unfolded state. HUF, sorry, HF minus HUF. Here HF is less than HUF. So what is the value? You will get a negative value. Delta H is negative. It's exothermic. This one is exothermic. Then what is the condition for spontaneity of a process? The condition is delta G is equal to delta H minus T delta S should be less than 0. Delta G should be less than 0. This is the condition. Suppose if you take SUF less than SF, then what is the delta S? Delta S is equal to folded state entropy minus unfolded state entropy, SF minus SUF. Here which one is greater? Yes, F is greater. So what is the term you will get? Positive term. So for A, what about delta G? Delta H is negative and delta S is positive. So this one is negative. T is positive term. When you multiply with the positive term, you will get positive, and here there is a negative. Finally, the minus T delta S will be negative. Delta H is negative. So delta G obviously negative. In this case, delta G is negative, so the process is spontaneous. Delta SUF is equal to 0. Suppose when delta SUF is equal to 0, what is T delta S? Delta S is equal to SF minus SUF. When this one is 0, it will be equal to SF. We know that entropy of any state is positive generally. So SF is positive, delta S is positive. Again, delta H negative, delta S is positive. So the whole delta G will be negative. So in this case also the process is spontaneous. SUF is equal to SF. Then what is delta S? In this case, delta S is equal to 0. So this term will be 0. Delta G obviously negative since delta H is negative. So in this case also the process is spontaneous. If you take this one, SF minus SUF greater than HF minus HUF by T. Okay, what is this one? SF minus SUF means it is the delta S and this is the delta H. So if you write this one, delta S is greater than delta H by T. If you rearrange this equation, you will get delta H minus T delta S is less than 0. It means delta G is less than 0. So the process is spontaneous. What is the reaction? What is the answer? A, B, C, D, all are correct options. The soft Lewis base is, okay, which Lewis bases are soft, generally in size, large size, and the donating atom is less electronegative and more polarizability. Okay, these are the conditions for more polarizability. Then the bases will be soft bases. I minus large in size, so it's a soft base. Here carbon is the donating atom, less electronegative, so CO is also soft base. H minus large in size, so this one also soft Lewis base. And CH3NC, here the donating atom is carbon. In this case also the carbon is the lone pair of electrons are attached with less electronegative carbon. So the CH3NC is soft base. So for this, what is the answer? A, B, C, D, all are soft bases. Okay, boron atoms are given. Okay, which shows three signals in proton NMR spectrum with the intensity ratio of 1 is to 2 is to 3. Okay, you have to identify how many different types of protons are there. How many non-equivalent protons are there? Suppose if you take BCH3 thrice, this one is all protons are A type of protons, and in this case all protons are B type of protons. Here you can find only two signals, not three signals. So this one is incorrect. In this case, this one is A type of proton, and this one is B type of proton, and this one is C type of proton, and this one is D type of proton. Here you will get four signals, not three signals. This one also wrong. Here this is the A type of proton, and this is the B type of proton, and this is the C type of proton. How many A type of protons are there? Here we have three, and B type of proton, for CH2 you have two. These CH2 three times, so it will be 6, and CH3 three times, it will be 9. What is the ratio? 1 is to 2 is to 3. You have three signals with ratio of 1 is to 2 is to 3. C is correct. In this case, this is A, and this is B, and this is C. Three different protons we have. And what is the ratio? This one is 3, 2 into 3 is 6, and 3 into 3 9. In this case you have 1 is to 2 is to 3. You have three protons, three non-equivalent protons, and you will have three signals. What is the intensity? 1 is to 2 is to 3. So D is also correct. Then what are the correct options? C and D are the correct options. The transition metal complex with zero magnetic moment, okay, mu should be 0, and zero dipole moment, and CFSE of minus 2.4 delta naught is. Okay, here dipole moment, zero dipole moment. First, we take zero dipole moment. Which complexes have zero dipole moment? Suppose if you take MnCO5 CH3, this is a structure Mn. Okay, this is a structure. You have 5 COs and 1 CH3. 1 CH3. In this case, Here the dipole moments will be cancelled out in this direction, this one in this direction, this is in this direction, this direction. But in this direction and in this direction, this is let us take in this direction. There is no cancellation of CO CH3. The dipole moment of MnCO bond and MnCH3 will not be cancelled out. So here you have some dipole moment, mu naught is equal to 0. Dipole moment will not be equal to 0. So this one is not correct. For this dipole moment is not 0. So this one is incorrect. And this one trans N ethylene diamine chloride. In this case, dipole moment is 0. In this case also, dipole moment is 0. And in this case also, dipole moment is 0. In first case, the dipole moment is not is equal to 0. And 0 magnetic moment. Suppose if you take this one, what is the electronic configuration? The oxidation state is nickel 2 plus. It's a low spin complex. So you will have this is the electronic configuration. The 8 electrons you have, Ni2 plus 8 electrons. So these 8 electrons will be filled into like this. So all are paired electrons. So the magnetic moment is 0. But if you take CFSE, what is the CFSE value here? Crystal field stabilization energy. This one minus 0.4 for one electron, minus 0.4 for this plus 0.6. Here how many electrons are there? 6 electrons are there. Minus 6 into 0.4 means minus 2.4 plus, and 0.6 into 2 it will be 1.2. So minus 1.2 delta naught. So this one is not minus 2.4 delta naught, but for this complex is minus 1.2 delta naught. Suppose if you take this one, what is the oxidation state for this complex? Here the total charge on complex is minus 1, x 4 into minus 1, and H2O is 0, so x will be plus 3. So if you take cobalt 3 plus, what is the electronic configuration? It will be D6. It's a low spin complex. Strong field ligands here you have. So this is the D6 electronic configuration. So the 6 electrons will be filled in T to Z level. So what is the stabilization energy? 6 into 0.4 minus 0.4. So it will be minus 2.4. Okay. In this case, magnetic moment 0, dipole moment 0, and CFSE is minus 2.4. If you take this one, what is the oxidation state? The total oxidation state is minus 4. The total charge is minus 4 x, and for 4 into minus 1 Cn minus, and 2 into minus 1. So what is the charge? The charge is plus 2. The oxidation state is plus 2. If you take Fe2 plus, Fe2 plus, what is the electronic configuration? Again D6. These are strong field ligands, so low spin complexes. For D6, what is the CFSE? Minus 2.4. This one also correct. So what is the answer? C and D are the correct options. Achiral stereoisomers. Okay, which are achiral stereoisomers? This one exhibits a trope isomerism. Here there is a chiral axis. The chirality due to chiral axis. Okay, in this case, here the two. What is the another substrate? The another substrate is hydrogen. Okay, in this case, if the two substances which are attached to this carbon are dissimilar, then the compound will be chiral. So this one is chiral. This one is chiral. Here hydrogen you have, here you have CH3. These are two different groups. Here you have CH3, here you have hydrogen. So here there is no plane of symmetry. So the molecule is chiral. Biphenyl complexes, biphenyl compounds. In this case also, when these two substituents, the ortho substituents, when the ortho substituents are two different substituents, then the compound will be optically active. This one also, it is due to chiral axis. Here also two different atoms, so this one also chiral. It can rotate plane polarizer light. Suppose if you take this one is asymmetric center, and this one also asymmetric center. But even though this molecule has two asymmetric centers, here there is a plane of symmetry. Okay, you can divide the molecule into two equivalent parts, and these two are mirror images. So this one is achiral. Even though it has chiral centers, as a molecule, it's a achiral. Here you have chiral centers. This one is one chiral center, and this one also one chiral center. But due to plane of symmetry, okay, this is a plane. This one cuts the molecule into two equal parts, and these two equal parts are mirror images. So this one is achiral. So what are the achiral stereoisomers? C and D are the achiral stereoisomers. The compound which will have only two signals, here only two signals in proton NMR spectrum with 3:2 ratio. Here in this case also you have to identify number of non-equivalent protons. Here you have CH3 and CH3, both CH3 similar chemical environment, so A, and here there is no hydrogens. Here you have one hydrogen, 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 and hydrogen. So this one is different, B, B, this one is different, C and C. So here you have three peaks, three signals. In this case, how many signals you have? Three signals. So this one is not correct. Suppose if you take this one CH3 and this one also CH3, and here there is a hydrogen, 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 and hydrogen. These are hydrogens. In this case, A, and this one is B, different proton, and this one is C, and this one is D. Here you have four signals. And if you take this one is CH3 and this one is CH3, so this one is A and A. And if you take these protons, hydrogen, 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 and hydrogen. Suppose if you take any proton, that proton has same chemical environment. Suppose if you take this proton, this one is attached with carbon double bond, single bond, double bond, and C double bond O, and here also C double bond O. Suppose if you take this hydrogen also, you have double bond, C double bond, and single bond, C double bond O, and here single bond, double bond, and single bond, C double bond O. Same chemical environment. So these are A, and all these four will be B. Then what is the ratio? What is the ratio? A and B, if you take, how many A's are there? 6 A-type protons and 4 B-type protons. It is 3:2. So C is correct option. If you take this one is CH3 and this one is CH3, CH2 and CH2. A type of protons, these are A type of protons, and here CH2, this CH2, both have same chemical environment. So this one is B, this one also B. Finally, you have A type of protons. How many A type of protons are there? 6 A type of protons, 4 B type of protons. Again, the ratio is 3 is to 2. So what is the correct option? D is also correct. C and D are correct options. The correct sequence of reactions for the synthesis of the following molecule. Okay, this is a molecule. What is the correct? Let us take A. Okay, what is the starting material for A? This is the starting material 4-idophenol. This is the 4-idophenol. When you react with the magnesium, there is a formation of Grignard reagent, magnesium in triether. So here OH and here there is a MgI. And when you react with the cyclopropane carboxaldehyde, this is a cyclopropane carboxaldehyde. And when you react with C double bond O, this is a H. Okay, then what is the reaction? In this case, what is the reaction? You will get this phenyl group. It can act as nucleophile and attacks on this carbonyl carbon, and finally you will get upon acidic cyclopropane carboxaldehyde, you will get this one is OH, and this one will be COH, and this is a cyclopropyl ring. In next case, you have to react with the methyl iodide. Here, there are two nucleophilic OH groups, this one and this one also. This is the benzene ring. This OH actually, when compared with this OH is more nucleophilic, because in this case the lone pair of electrons are participating in the resonance. In this case there is no participation of lone pair of electrons, so these electrons will attack. Then what is the product? You will get methylation at this position, not at this position. But our product is methylation at this position, not at this position. So A is not correct. And cyclopropyl bromide, suppose if you take cyclopropyl bromide, this is a cyclopropyl bromide and reacted with magnesium. So you will get cyclopropyl magnesium bromide. And this one is reacted with 4-hydroxybenzaldehyde. This is a 4-hydroxy OH and benzaldehyde, C double bond OH. Here this one attacks on this C double bond O, so you will get finally this is a OH and here you will get OH, and this one is H, and this is a cyclopropyl ring. Let us take this is CP ring. So when you react with the methyl iodide, in this case also which one participate? These electrons, these OH will participate. So methylation takes place at this OH, not a phenolic OH. So this one is also not correct. Suppose if you take 4-idophenol, this is a 4-idophenol. This is the ido group and this is the OH. And this one is treated with methyl iodide. Then here there is a SN2 type of reaction and there is a methylation. Here there is a OMe and here I. So when you react with magnesium, it will form MgI, and when this one is reacted with cyclopropane carboxaldehyde, then there is a formation of this complex. Okay, this one is correct. Suppose if we take, So here you will get MgI. This one is OMe, MgI, and if you take cyclopropane carboxyldehyde, C double bond OH, this phenyl ring attacks on this one. So finally you will get this compound. Suppose if you take cyclopropyl bromide, this is the cyclopropyl bromide, and this one is reacted with magnesium, and this one is MgBr, and here 4-methyl 4-methoxy benzoate. You have to react with 4-methyl, okay, 4-methyl 4-methoxy. This is a 4-methoxy OMe benzoate, methyl benzoate, C double bond OMe, OMe. We know that when RMgX is reacted with esters, you will get tertiary alcohol. Here you will get two cyclopropyl rings at this position. So you will not get this product in this case. So this one also wrong. C is the only correct option. The organometallic reagent among the following is, okay, lithium divinyl cuprate. This is R2CuLi. This one is Gilman reagent. Here there is a bond between carbon and Cu. So when there is a MC bond, when there is a direct bond between metal and carbon, those compounds are called as organometallic compounds. So this one is the organometallic compound. Lithium diisopropyl amide. This is the lithium diisopropyl amide. Here N minus, lithium plus. Here you have two isopropyl groups. Okay, when you take this compound, there is no direct bond between metal, that is lithium, and carbon. There is a direct bond between lithium and nitrogen, but there is no direct bond between carbon and lithium, so it's not organometallic compound. Potassium tertiary butoxide. This is the tertiary oxide, butoxide. If we take potassium tertiary butoxide, here potassium metal is directly attached with oxygen, not directly with carbon. So this one is also not organometallic compound. Isopropyl magnesium iodide, it's a RMgX type compound, Grignard reagent. Here you have metal carbon bonds, MC bonds, RCM bonds. So it is a organometallic compound. So what are the correct options? The organometallic reagents A and D. A and D are the organometallic compounds.